Line segments. Line segments come from lines. They are simply the product of breaking off the arrowheads on both ends of a line, meaning that the line no longer goes off in two directions unstoppable. It now has a length. Once you do this line segment from A to B has a specific length that can be measured. While the name of the line segment itself is line segment AB, notice the little symbol that I put above the letters. It's a miniature line segment symbol, or it might have the name BA. Doesn't matter which way you read the line segment, it's the same line segment either way. If I actually were to measure it, and let's say I measured it and it had a measure of 8 units, inches, centimeters, miles, whatever, then I could say that AB without the bar above it equals 8 units, whatever those units are. This means the distance from A to B. When you see it without the bar above the letters, we're talking about the distance of that segment from one point to the other. We're talking about the length of the line segment itself. Now, if you'll notice, a third point has appeared on this line segment. This is point C, and point C is actually between points A and B. Now, when I say between, that means it could be anywhere from close to B, closer to A, or it could be more dead in the middle. Any of these locations are legitimately between points A and B. Now, if you'll notice, the longer piece that was created by point C is definitely shorter than the entire line segment AB. And likewise, the smaller piece here is shorter than the entire line segment AB. So doesn't it make sense to you that if you put the longer broken piece end to end with the shorter broken piece, and you were to add these distances up, you'd have the full length from A to B. This concept is called segment addition. Segment addition, mathematically speaking, says this. We can take the small piece from A to C. Do you see where that is? And we can add the small piece from C to B. Do you see where that is? And together those two make the full length from A to B. Now, looking at the second example of line segment AB, and I've moved C. Point C I've moved more toward the middle. Do you see what I've done right there? That means that this small piece should be equal to this small piece. And we could still say A to C plus C to B would equal the entire A to B. But there's more you could say. Couldn't you also now say that the piece from A to C is equal to the piece from C to B? Now that's a totally different equation. And I'd like to bring up a new way of marking a picture. If indeed C is dead in the middle of line segment AB, you can actually mark each little piece as being equal to itself or congruent. Congruent means this one piece is equal to another. It's the equal word for geometry pictures. When I put a single slash mark right here on A to C, and I put another single mark on C to B, I am identifying in the picture that these two pieces are equal in length, equal in numbers. If one of the two pieces, say, had 2 hash marks on it, that's indicating that they're not equal. But since C is dead in the middle, I have to put 2 marks. If it's going to be 2 marks on one and I want them to be equal, I have to use the same number of hash marks. I could also put 3, but then I'd have to make them match on each side. So this picture is now communicating that C is in the middle of AB. And when you are in the middle of something, you are called a midpoint. And that should make sense. That compound word right there describes exactly where it would be located. C is in the middle. These marks are called congruence marks. And that's an R right there, congruence marks. And the symbol for congruent is an equal sign with this little wavy, figures above it. This symbol right here means the word congruence. It's an equal sign with the squiggle above it. Let me make sure you understand this symbol because this is your friend in geometry. When you see that symbol, it means you have figures or images or pieces of drawings that are congruent. They are equal in size and shape and measure. In algebra, you normally just have an equal sign. You're talking about numbers. This congruence idea is our geometry way of saying two figures are equal. Okay, so let's recap what we've done. When you are talking about line segments, there are two mathematical things that could happen. One is you could break a line segment into two pieces. So here's a line segment, and we'll just call it line segment AB. If a third point occurs, C, and it's simply between the end points A and B, you can add the two smaller pieces, A to C, plus the C to B length. If you put them together end to end, you get the full length A to B. This is small piece plus the other small piece equals the whole segment. Or we could have a different situation. We have a midpoint. So let's say we have a line segment, PQ. Here's point P, here's point Q, and in the middle we have point M. And I know it's in the middle because I see these congruence marks that have been placed on the picture. Even if the picture is poorly drawn, I am reading the marks because that's how geometry plays. And the marks are telling me that those two small pieces are equal. So P to M should be equal to M to Q. And this equation is really just in the format of piece equals piece. These are technically the only two equations that we have in geometry. We spend an awful lot of our time in a picture creating an equation from the picture that says piece plus piece equals whole, or if the situation is right, we end up working with an equation that is in the format of piece equals piece. Review any of this that you need, look back through the video, and then move on to the example videos that go with line segments, and work your way through those before you begin to practice.